Steam Chemist here, and I'm back with some more fun for you today. As you can see, you see a lot of different types of things on my table. These are materials that we're going to be working with today. Let's run through them real quick. Water. This is dish soap. Dish soap. Done. Dish soap. Did it again. Miss Butterworth's got some maple syrup. This is vegetable oil from Baruski. This is corn syrup. This is light. You can have dark, whichever floats your boat. This is some shaving cream. Shaving cream. This is honey from the bees. Some cups. Gotta have some cups. These are pipettes. You don't necessarily have to have these pipettes. These are used to take liquid in small amounts out of one vessel and put them into another vessel. But yeah, this what you should have though is like spoons, or this is Popsicle Sticks. This is just to stir our mixtures together once we add them into our cups to change the color, just in case we want to change the color. Also, milk. Milk does the body good. Milk and tall jar, a tall glass, a vase, a vase, depending on how much liquid that you have. Now, mind you, we don't want to be wasting liquids today during our experiments. So if you do not have all of these, that's totally fine. If you have most of these, that's totally fine. Even if you have 3 or just 2 of these, that's totally fine. What we're going to do is think about liquids today. As you can see, all of these materials are mostly liquids. Oh, and the tray, this tray, so that we can see some liquids flow. So liquids, we remember liquids. Liquid is a state of matter. Matter is things that take up space. So liquid, this liquid right here is vegetable oil. This liquid is different than this liquid. This liquid is totally different. And you can see, even if I turn it upside down, that it moves different as well. You see it moving different, moves different. Look at So the term, we're going to go through a lot of different terms today dealing with liquids. The first term we're going to talk about, though, is viscosity. Viscous. How viscous is it? Try to say that word. Viscosity. Viscosity is thickness of a liquid. So another way of saying how viscous something is, you can say how thick something is. So how thick is this? How viscous is this liquid? We can have a high viscosity or low viscosity. Low viscosities usually have very fast movements. But things with a high viscosity or a high thickness have low, slow movements. Similar to this honey. Honey is very thick, or molasses. If you have molasses, you can use molasses. But we'll get to that later, switching out liquids and all that jazz. But thickness, let's, for instance, take some soap. How thick is this soap, you think? So let's take one of our cups and add some to it. So if I just let this kind of hang upside down, you can see gravity is pulling down the liquids from this container here. But I can squeeze it. That's what this is for. Squeeze it, and you can see that it's still coming down, not relatively fast, but it has some thickness to it, right? It has some thickness. It's a viscous liquid. But it's not as viscous as some more of these liquids over here. For instance, let's get something that's a little bit more viscous. So here's this. See, you can see it kind of has a wiggle. See how it slides side to side if I give it some motion. Let's take out our little tight on the top. This is our corn syrup, light corn syrup. So now, check that out. Look at it flow. So this is a little bit more viscous, or a lot bit more viscous actually, than our soap here. And you can see the difference right there once I put the top on, actually. And if I go side to side, this moves slower than this. This moves much faster. As you can see, it's almost pour it out just a little bit. But these two liquids have different types of viscosities. Oh, screw. Coming back. There you go. Can you see them now? So these have different viscosities. So I can take, for instance, this right here. Take our popsicle sticks and put them in, and I'll pull it up. And you can see this over here on my left side is moving much faster than our corn syrup over here on the right side, because it's much more viscous and thicker of a substance, the corn syrup is, opposed to our liquid soap. So viscosity, but we don't want our corn syrup to be clear. We want to, let's see, what color shall you be? This is pretty, nah, let's do this one. Boom, it's a little pink. Boop. And you can go ahead and color yours if you'd like to. If you don't have to. Alright, boop, 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 boop. And you want to see a color change when you mix that liquid into the other liquid, and now we have pinkish red corn syrup. See? Same thing, different color. Alright, so we have our corn syrup, which is this. We have our liquid soap, which is that. Let's put them on our tray. Let's do that. Now, take another cup, and let's look at our vegetable oil, how viscous that is compared to, say, water. So water, remember, water and oil do not mix at all. So let's take our vegetable oil. Vegetable oil is already colored, so we don't necessarily have to color it, but I'll pour this out, and look how fast it's already flowing out. Too fast. So you can say this has a very, very low viscosity. It's very, very fast. Fast moving liquid. Now, let's do water. I'll try to do this with one hand so y'all can see how fast this is, just as much as I pour it. And you know how water flows, how fast that is. So you have to give it a little bit more control so it doesn't splash around. So now I'll take 2 spoons, forks, sticks, popsicle sticks, and down we go. And now, as I pull this up, you can see our water doesn't necessarily even want to stay on the popsicle stick. But look, our oil is sticking to it. It's thicker. It's a thicker liquid. But when we think about density, how dense is something, the water actually is more dense than oil. That's why oil floats on top of water. Even though this oil is thicker, it looks like it's thicker, its density, which is another term. Let's talk about density. Say density, density. Density is a volumetric measurement, and that measures weight per volume. So how much does something weigh based on the volume that is taken up? Usually in grams per milliliter or grams per cubic centimeter, which is the same thing as a milliliter. And what we have, for instance, this right here, if I take this water and pour it in here, you can see the water goes to the bottom because the water is more dense. I'll take it and just pour it all in there since it won't really overflow. But you can see now the water goes to the bottom because it's more dense. We did this activity before, and now we're going to add more liquids to it. First, we just had our water and our oil. But if I was to take, for instance, this honey here, this honey is much, much, much more dense than both of these. And you can see it goes straight to the bottom. The honey does. See? Honey. And it looked like a little gas pocket started to float up. See that? Oh, no, that's oil. So as I poured down the honey, there was some oil that got trapped in the honey, and that oil is now resurfacing back up into the into its relative space. As you can see, look, watch, here it comes. Let me shake it, 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 shake it. I see it's trying to reach, because remember the oil is so lightweight. It doesn't want to stay down there where the water is. It's less dense than water. But eventually, look, here it comes. Here it comes. You see it? I hope y'all can see this. And this is so entertaining. There it goes. There it goes. Bloop. Gotta love it. So we'll set that there. I hope y'all as excited as that was. So now let's move on to some more. Let's put this right over here. Just let that chill. If any oil wants to relieve itself and go right back to the surface, it will. We got our water. Let's refill our water. And we're going to color our water green. Because I don't see anything up here that's close to green. And water. Boom. Green. Here we go. Here we go. Where we go. Stir this up. Now we have green water. Green water. Green water. Green water. Pause. I need my rubbing alcohol. It's in the garage. Rubbing alcohol. Also, rubbing alcohol. And let's go ahead and get some rubbing alcohol. And you can see this is also a clear, colorless liquid. That's why it's important we do not eat or drink in science. This rubbing alcohol is not good to digest. It looks clear and colorless just like this. If I was to take this and put green in there, you would think that it was also green water because we just made this water green. But let's take this green out of the way and make our purple rubbing alcohol. And with rubbing alcohol and water, they are very, very similar. Is that mixing? It's mixing. They're very similar in viscosity. But when it comes down to its density, they're very different. For instance, rubbing alcohol floats on top of oil, and the oil floats on top of water. So their densities are different. We'll do that here in a second. Is that purple? Is that purple? It's kind of purple. It looks kind of dark. Let's kind of change this up. Mix it up. So rubbing alcohol. Rub-a-dub-dub. In the tub. Which rubbing alcohol. It sanitizes. It's very, very good for you. Just make sure you dilute it with water. Let's make it, well, we have red, we have blue, we have green. Let's do a little, let's mix these two together. Well, this is a darker red. Let's do red and purple. I think I put too much purple in there last time, so let's do a little red. Boop. And then just a touch of purple. Let's see what this does. Oh, that's pretty cool. That's relatively cool. Yeah, I like that. It's like a maroon. Alright, so enough with the color catastrophe here. Now we have our alcohol. Let's put some oil in this. So this is our rubbing alcohol, and we're going to add our oil to this. And you'll see the oil. Where's the oil at? Top or bottom? Right, it's on the bottom. So the oil is more dense than the rubbing alcohol. Boom. Denser liquids. Now, let's move on to some of this. Mrs. Butterworth. Get some Mrs. Butterworth and throw her in like that. Mrs. Butterworth. Boom. Now this syrup is very, very thick. It has a very, very thick viscosity. This water, however, is thinner. So we obviously know this syrup is maple syrup, rather, not the light corn syrup. This corn syrup is different. Actually, let's do that. So we have our corn syrup, and it's clear. So we should see a difference, very, 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 very big difference. So it's either going to float on top or go on the bottom. Let's see. And boom, just like that. You can see the darker stuff, which is the maple syrup, is on the top. And the lighter stuff, which is the clear corn syrup, that which just got tinted by the darker maple syrup, is now on the bottom. See that? The like caramel looking color down at the bottom. Cool beans in a hot pot. Now, let's put this all together. Put this all together with our container here. Boom, 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 boom. So if you have a larger container, you can use a larger one. If you have a smaller or a thinner one, you can use a thinner one. I'm running low on some of these liquids, so I'm gonna go with the Gusto. No, I'm not gonna go with the Gusto. So now let's start with building our density column. So this is a column, and we're gonna build a density column from the heaviest, thickest liquid to the thinnest, lightest liquid, which should float right on the top. So which one of these do you think is the more dense liquid? Which one has the more bulk? Which one has more grams per milliliter? Which one has more weight per milliliter? Let's see here. So we know water is very movable. It's moving fast. This is probably up right a little bit. It's got a little wiggle room. So it's between these two, perhaps. And then, oh, don't forget about our honey. Our honey. So we either got honey, we have maple syrup, or our corn syrup. So between these three, which one of these do you think is the heaviest? You're right, the one I have in my hand here. So this one is the heaviest. So first, go ahead and grab your column, take out your honey, and get you a nice level of honey in there. Nice level of honey. Honey child. Is that good? That's pretty good. Can y'all see that? Is that seeable? Is that seeable? So we have our honey layer. Honey layer. Alright, I'll put that there. Honey layer, let's move this to the side. So we got our honey layer. And now we can go ahead and put a former experiment into practice and utilize our results from it, which is a part of the scientific method. We know that maple syrup is lighter or less dense than our light corn syrup. So we can already attest because our thickest, next two thickest liquids are our corn syrup and our maple syrup. There you go, ain't your mama? There she go. And we can go ahead and just pour this on in. And we have some red right over here. Remember, earlier we made our red corn syrup. So let's go ahead and not waste. Waste not, won't not. Put that like so. And slowly add it. Slowly add it, because we don't want to disrupt anything. And do it as much as you can in the center so that you don't get nothing stuck on the sides. There we go. Look at that finesse. Look at that finesse, y'all. You want to make the layer just as much just as high as the honey layer, if possible. If possible. Let's go ahead and get that last drip. Drip. Got it. Now let's move along. So next thickest is our soap and our maple syrup. We already know maple syrup got a little bit more thickness. So we'll just keep it as is. See what's going on over here. What was this? This was our oil and our where'd it go? Our alcohol. So let's go ahead and add our maple syrup. A little bit more finesse action. I'm gonna try to do this as much as possible because remember, as we go up, the less viscous and less dense our material. So let's go ahead and you can see it starting to rest on top. Whoa. Here we go. And also make that about the same width or depth as your last two. Booyah! Coming straight to ya. Alright, so we have those three looking lovely, looking pretty lovely, if I say so myself. Now we have those. They're going to rest on top of one another. Next in line, we have our soap. Soap, as you can see, still got that thickness to it. Now we'll take our soap and with a little bit more finesse, it should rest right on top of our syrup, maple syrup that is. So we should see blue. We should see blue. I see blue. I see blue. How about you? Oh, this is dope. I love density columns. So there we go. Density is real. You can see the blue now resting ever so softly right on top. Right there, and the gas bubbles in between are just going to float between the two. Remember, gas bubbles are really, really lightweight, and they eventually will start to rise up to the top. All right, now we'll move on to some more fun. So what we have next? We have rubbing alcohol. We have milk. Oh, we ain't got to our milk yet. We have water, vegetable oil. We know water and vegetable oil. Obviously, water is going to be below vegetable oil. We have our oil and our rubbing alcohol. So we know we have our top 3 layers. We have 3 layers right here. We got rubbing alcohol, oil, and water. So we know that is correct. So we're going to leave that here. Let's do a little something with milk. A little something with milk. Let's bring out the milk and see where our milk lies in this. Oh, there it is. Soap. There it is. I'm looking for the soap. Soap. Between the water and the soap, I meant. Milk and the soap. Milk and the soap. So soap, here's our milk and here's our soap. What's our soap doing? Oh, sucky now. Look at that. The soap is on top of the milk. So that means we need to do a little bit of fun. Let's get out a pipette and let's get some milk and a cup, because we are going to transfer this milk into our density column. Because obviously our soap, I forgot about our milk sitting over here. Our soap, as you can see, is less dense than our milk. So our milk is chilling right there underneath, and our soap is chilling right on top. So what we're gonna do here, let's see if we can add it in here and see what happens. So what should happen is this milk should go right in between the soap and our maple syrup. Watch. Look at it. Oh, that is cool. All right, let's let that chill for a second. Let that level out. Level out. So our milk eventually is going to sit right there on top of our syrup, and our soap is going to start to surface. So you can see it already starting to come together, and that milk is going to congeal into more of a compact solid. But it's not a solid, it's still a liquid in there. Alright, so that is so dope. I forgot about the milk, but I'm glad I did, because this got me another little science experiment I can do. Alright, let's add some more soap. Alright, boom. Soap, just so you can see the difference right there. Now you can really see the soap and the oil, the soap and the milk separated. Alright, so now, let's go to water. So our water should now rest on the soap. Let's see. There we go. Starting to mix with that. Where we go? We got a little green layer on top right there. I poured down a little bit too fast, and our milk got pulled up a little bit, because remember, milk and water are synonymous. All right, let's get another cup. All right, vegetable oil. Here we go. Vegetable oil. Let's get our vegetable oil. Vegetable oil, we know, is gonna sit right here on top. I'm running out of space. There we go. Got our oil. Now we're starting to get like a greenish color, because our oil is mixed in with a little bit of that green from the water. So we got a green layer right here of water mixed with a little milk, soap, and then our milk, and then our corn syrup, well, our maple syrup, our corn syrup, and our honey. Now let's top it with a little floater. Here's our floater. Floater is our, let's do this color. This is our purple. Remember we made it like a little, earlier we made some maroon, but now we're gonna top it with purple. And remember, I'm coming from a very, very high distance, so it's really gonna push stuff down, especially with all of these thinner liquids, since all these liquids are thinner. But if you just let it sit and let it kind of just die down a little bit, all of the motion, it will eventually start to even out, and the densities will take over. You can already see down here the milk has made itself a nice little home. The soap is too. We got a little water layer right there in our green. This rubbing alcohol is just taking over. But the oil is right there nice and tight, hovering above the top of our water that has water, milk, and rubbing alcohol in it layer. But rubbing alcohol is still on top there. We'll let that sit. Alright. And put this over here. Put this. Boom. Boom. Alright, pull these out, pull one of these out. And let's go to our water and our shaving cream. Let's pour some water in here. Water. And we're going to talk about saturation real quick. Saturation. How wet something is, or how moist something is, or how much liquid is in something. So water, nice shake. Shaving cream, and you can see our shaving cream sits on top of our water, nice and cool. Let's chop this off. There we go. There we go. So the more that I saturate this, more it has the ability to rain. There we go. Let's do some red. This is so cool. Science. Wicked. All right. Thank you all for your time today. I could do this all day long, obviously. I appreciate you. I really hope you enjoyed today's lesson on density and viscosity and thicknesses of liquids, and how when you add a lot of liquid to one thing, it gets overly saturated. For instance, if I take this and add it into here, nice and saturated. All right. Happy experimenting, safe experimenting. And until next time, see you soon.